Section 4.3 Part 2 is digging just a little bit deeper into solving systems using the elimination method. Now this time what we need to actually do in order to eliminate a variable is set up the elimination step by multiplying one or both of our equations by a constant number so that we can actually cancel our variables out. So we still have the same goal. We're still looking for the point where our two lines cross, but we're going to have to add a little bit of a twist to what we learned in 4.3. So first of all, I want to decide which variable I'm going to eliminate. So in our first example here, let's try to eliminate x. So what I want to do is make sure that when I get my equations ready for the elimination step, I have equal but opposite coefficients with my x variable. So what I'm going to do is take -2 and I'm going to multiply it by that entire first equation. That means that I have to take the -2 and distribute it to all of the terms on the left side and the right side of the equation. Okay? If I drop that down, what it's going to give me is -2x. -2 times y is -2y. And -2 times -1 is a +2. So we have equation 2, which we're going to leave alone. Now we rewrote equation 1 by multiplying it through. And we can add these together. So 2x and -2x, those are going to cancel out. 5y plus -2y is 3y. And 4 plus 2 is 6. And now the rest of the process is exactly the same as normal elimination. So I solve for my first variable. I'm going to divide by 3 on both sides. I get y equals 2. And then I'm going to take that and I'm going to plug that value in for my y value in the first equation. So that's going to give me x plus 2 instead of x plus y equals -1. And I'll solve for x. Subtract 2 on both sides gives me x equals -3. Okay, and then again, final step is always writing your answer as an ordered pair, -3, 2, because what that represents is the point where the two lines cross on our graph. So example 2, same process. I want to decide which variable to eliminate. In this case, I could eliminate x or y because the second equation, both numbers are multiples of the numbers previous. So 3 times -3 would give me -9, or -2 times 4 would give me -8y, and that would let me eliminate y. So since we eliminated x in the first example, let's go ahead and eliminate y, just to see if it works both ways. So if I have a positive 8y in my second equation, I want to create an 8y in my first equation. So I'm going to multiply that first equation by 4. And again, we need that 4 to distribute to all 3 of our terms. And we can bring equation 1 down here. 4 times 3x would be 12x. 4 times -2y is -8y. And 4 times 0 is still 0. Okay, let's go ahead and add those up. 9x plus 12x is 21x. My y terms cancel out, and 7 plus 0 is 7. So if I divide these out, divide everything by 7, I'm going to get x equals 1/3 when I reduce that fraction. So same process, take that x value, we're going to plug it into our original equation. Now you can plug it into either one of the original equations, but I would always choose the one with smaller numbers to work with. That's going to make your life a little bit easier. So we have 3 times x, so 3 times 1/3, minus 2y equals 0. Okay. 3 times 1/3 is just going to give us 1 minus 2y equals 0. We can subtract 1 on both sides. We get -2y equals -1, and we can divide both sides by -2 to get y alone. So we get y equals negative divided by negative is going to make a positive 1/2. So our final solution is 1/3, comma 1/2. Okay, so not too bad. In both of these examples, we've had to only multiply one of our equations by a number. You can see in this next example, there's no direct multiples between x's and y's. So it turns out we're going to actually multiply both equations by a number. So I'm going to decide to eliminate x. And in order to do that, we're going to look at what the least common multiple of 5 and 6 is. In this case, it's just 5 times 6. They don't share any factors, so it's equal to 30. So I'm going to make the top equation create a 30x, and I'm going to make the bottom equation create a negative 30x by multiplying the top equation by 5 and the bottom equation by negative 6. So that's going to give me, I'll drop this second equation directly below it. It's going to give me negative 30x. Negative 6 times 8 is negative 48y. Negative 6 times negative 1 is positive 6. And I'm going to drop my top equation below that. And that gives me 30x plus 35y equals 20 if I'm distributing that 5 into each term. So now I can add these two new equations up. You can see my x's cancel. Negative 48 plus 35 is negative 13y, and 20 plus 6 is 26. So again, once I eliminate a variable, I have only one variable left, and I can solve for that variable. So I'm going to divide both sides by negative 13 to get y alone, and I get y equals negative 2. We'll take that value. Let's go ahead and plug it into our original equation, and the first one is going to be easier. We've got smaller numbers to work with. So I get 6x plus 7 times negative 2, which is y, equals 4. That gives me 6x minus 14 equals 4. I'm going to add 14 to both sides, and I get 6x equals 18. And I'm going to divide both sides by 6 to get x alone. I get x equals 3. So I've got x, I've got y, and I'm going to write my final answer as, well, give it a little more space over here. Put those together, and I get 3 comma negative 2. So again, first three examples, if you're looking over your notes page, we got one solution where we had a single point where these lines cross. Now, remembering our two special cases, it's possible that we have parallel lines, so the lines don't cross, and it's also possible that we have the same line, which means there's infinitely many solutions. So we're going to take a look at the next two examples and see how that is going to look using the elimination step. So here in this first example, I see a 2x and I see a 4x. So I'm going to eliminate x by multiplying the top equation by negative 2. So when I distribute that through, it gives me negative 4x minus 8y equals negative 10. Add those up, the x's go away, the y's go away, so my left-hand side is just 0. And my right-hand side is negative 9 plus negative 10, which is negative 19. So this is a false statement. Therefore, there's no solution to this system. They have to be parallel lines. And our final example for the day, here we can eliminate, let's eliminate y because I have a positive 3y and a negative y. Eliminate y. I'm going to multiply the top equation by a 3, and we'll see what happens. That's going to create a negative 3y, so that's good. It's also going to create a 3 times 3 gives me 9x, so 9x minus 3y equals positive 12. And you can see when I add together my new first equation and my second equation, x's cancel out, y's cancel out, so I get 0. And negative 12 plus 12 is also 0. So that's a true statement. 0 equals 0. So we have infinitely many solutions. So as always, there's one example for you to try. Go ahead and try that problem and bring it to class with you.